Hi friends, here we have the pickle documentation about object serialization. It says the pickle module is not secure, only unpickle the data you trust. It is possible to construct malicious pickle data which will execute arbitrary code during unpickling. This is the most important part. It can execute arbitrary code during unpickling. Now, we save ML models in various formats, including pickle. These days, we download lots of models from the internet, whether it is computer vision, LLM, or any other AI models, and we run them locally, right? Now, these models are prone to malicious code injection. How do we detect such vulnerabilities? Fortunately, there is a library called model scan. Okay, so it says we are not scanning ML models with the rigor of a PDF file in our inbox. Okay, all right. So these attacks can happen for various reasons. They might try to steal our credentials or data theft, or it could be simply to poison the data or models. All right. It's very simple to use. All we need to do is input our AI ML model to the model scan. It try to detect various vulnerabilities and provide them with some severity score. Okay. What else I want to show from here? Okay, let's see an example. So for this purpose, we are going to train an ML model, and we purposefully inject some malicious code into the model and see how we can detect that and what are the consequences of it. Okay, so import TensorFlow, and we are going to train a simple classification model using this fashion MNIST data. All right, this data it's readily available. So we get the data, just do some pre-processing, and then return the train and test images as well as the ground truth labels. Okay, then here we define a very simple sequential model and define the compiler as well as the optimization metrics, and then train the model through model.fit. Okay, during the model training, we are printing some metrics. All right, and then we have a couple of helper functions. So this is to get the predictions. It takes the model and the number of predictions or the number of images we want to make the predictions for. So the class labels, and it get the data, again those images, and then make the predictions and print some stuff, the actuals versus the predictions, and also the confidence scores. Okay, a couple of more helper functions just to plot the image and show our predictions and the ground truth. All right, so just create a directory, and then here we train the model. Okay, so simply calling this train model, which is this function, it will define our neural network model, and then it will download the data using this get data function. Okay, it trains the model and prints some statistics. Okay, so that's what it has done. Okay, so we train the model for some 10 epochs, and here we have the scores, the final score, and then here we have save the model. Okay, to this path, TensorFlow models, safe model. Okay, all right, this is how it looks like. If you look at the folder, these are the model weights. Okay, the files we have, and then we can call our get predictions with the model and how many images we want. So here are the images, we have the predictions, the confidence scores, and then the ground truth label. So far so good, right? This is what we have been doing so far. So we train a model, we make the predictions, everything looking good. But let's say we downloaded this model from the internet. and somebody has injected some malicious code into the model. Now let's see an example how they do it in a second. But they could have taken the original model and injected some code, which we will see how, and created this unsafe model, and then save the model, and let's say we got the model from them and we try to run it locally. Okay, so we save the model in this unsafe model directory. Okay, then it looks exactly the same. So here we have the unsafe model. Now let's say what happens when we run this model. Okay, so we load the model. Okay, here we are just mimicking how we download a model from the internet, right? As I mentioned, it could be an LLM or computer vision or any other AI/ML model. So we downloaded a model from the internet and we load it into memory, and then we are trying to make some predictions or inference. Okay, so this part, it's looking good. We have the ground truth, the predictions, the input data, but here you can see some secret files have been exposed. Okay, now typically the AWS secret, it will be in .aws folder, but for this demo purpose we set the path as this temp AWS secret. So when we ran the model, it executed or it opened the content of this file with our AWS secret key and access or whatever is within this file, right? So that's one example of poisoning the model. Now, how do we detect? So here we have two models, right? One safe model without this injection, and another model which has this code injection. Now, what this library does is, it's very simple. So here, I just ran for both the models. So here, we are doing the model scan for the safe model, right? So this is where our model artifacts are. So you simply provide the path. So it does all its scans, and the summary, it says no issues have been found. Okay, because that model we saved straight out of TensorFlow. Okay, so no issues have been found. And then we took the same model, we did some code injection, and we saved that model as this unsafe model. Okay, so let's say this is the model we downloaded from the internet. All right, so when we do the model scan, this time it said it has detected two issues of risk high, and those two issues are, it's saying, okay, use of unsafe operator read file from module TensorFlow. Okay, similarly, use of unsafe operator write file from module TensorFlow. Okay, so it is saying the model has two high severity issues. These are related to the read file and write file operators from the TensorFlow module. Okay, let's see how that injection has been done. So this is the file, this is the function we call, right, to create the unsafe model. So we took our original model, run it through this function. What it basically did is, it read the original file or original model, and then it has injected this code into the model before we serialized it. Okay, so it has this TensorFlow write operator where it is trying to display the content of this file, right? This AWS access key and the secret. Okay, so if we have this file in our system, when we run the model or when we unserialize it, this code get executed automatically. Okay, so whatever the content of this file, that can get displayed or exposed. Okay, so that's one example of how this injection can be done, and how this model scan library can help us detect any vulnerabilities in our model. That's all for this video. Thank you very much.